Hello grade 11s. I'm going to be going through the 2019 May-June exam with you guys. So if we start, just to note that they've given you a formula on the front here, and they've also told us to round things off to 2 decimal places. Okay, starting with question 1. Solve for x. This is just a normal trinomial that you guys can factorize. So factorize the trinomial, and we get x plus 7, x plus 2, so that means that x is equal to minus 7, or x is equal to minus 2. Okay, with this one over here, again, solve for x. I must just take everything to the one side and set it equal to 0. Okay, now you'll notice with this that you can't factorize it in your head. Okay, and then that's when your formula comes into play. So you have to use this formula over here. So that's why it's important to get it into this form. So our a is equal to 2, our b is equal to 7, and our c is equal to minus 1. So I'm just going to substitute it into the formula, and we get x is equal to minus b plus minus b squared minus 4a times c all over 2 times a, and we get that. Okay, so you will get a mark for this, you will get a mark for that. Then just remember that they want us to round off our answer to 2 decimal places. So just put this in the calculator, the plus 1 first, and then put the minus 1 in, and you will get an answer of 0,14, or x is equal to minus 3,64. Okay, if you do not put it into decimal form, grade 11s, you will be penalized. Okay, now this one over here, I'm going to do it in 2 different ways, just so that you can see. The first way I'm going to do is I'm just going to take the 49 to the other side, or the negative 49. And then what I do is I take the square root of both sides to get the x on its own. And remember, if we take the square root of something, it's plus or minus. So we're left with x plus 4 equals plus or minus. The square root of 49 is 7. Take the 4 to the other side, and we get minus 4 plus or minus 7. What I'm going to do now is I'm going to split it. So we're going to get x is equal to minus 4 plus 7, or x is equal to minus 4 minus 7. And we get x is equal to 3, x is equal to minus 11. Okay, so that's the one way. The other way that I would do, and I'd probably recommend doing it this way, is because a lot of the times you guys forget to do the plus or minus. And that's just to FOIL this out. Okay, just remember that that means we have 2 brackets, x plus 4 minus 49 equals to 0. And I'm just going to FOIL that out. First outer, inner, last. And we get x squared plus 4x is plus 8x plus 16 minus 49 equals to 0. So we get x squared plus 8x minus 33 equals to 0. You can factorize that. And we get x plus 11 and x minus 3. So that means that x is equal to minus 11, or x is equal to 3. Now the reason why I suggest this way is because here you are forced to get your 2 solutions. Here, a lot of the time you guys forget to do the plus or minus. Okay, but either way is right. Okay, going on to question D. When we get something like this, we need to square both sides. Okay, so I'm just going to rewrite it, and I'll tell you in a second why I'm rewriting it. Okay, so let's square both sides. The square root and the square will cancel, and you're left with x squared minus 5. Be very careful with this, grade 11s. Remember, you still got 2 squared. So 2 squared is 4. Then the square root and the square will cancel, and you're left with x. Okay, take the 4x to the other side. And then we can factorize this. And we get x minus 5, x plus 1. So that means that x is equal to 5 or x is equal to minus 1. Now, a lot of the time you guys will just leave your solution like that. And that is why I rewrote it. Okay, we have to come back to this step over here just before we squared it. And I need to check my solutions. Okay, and this always happens when you do this with this surd and you square both sides. So I'm just going to check the solutions quickly and see which ones are valid. So on the left hand side over here, and then we'll have on the right hand side over there. So the first one I'm going to check is 5. So I put 5 into where x is. So we get 5 squared minus 5, and on this side here we'll get 2 root 5. Okay, so here we get 25 minus 5, which is root 20. And then if you guys aren't sure what root 20 is, just do it on your calculator. And we get 2 root 5. And as you can see, that 2 root 5 is the same as that one. So over here we have left hand side equals the right hand side. That means that this one here is a solution. But now I must check this minus 1 as well. Okay, so again, left hand side and then right hand side. So on the left hand side, I'm just going to make x minus 1. So we get minus 1 squared minus 5. And on this side here, we get 2 minus 1. Now, we can't take the square root of a negative number. So over here, there's no solution. And then here again, we would get a negative number. We would get the square root of minus 4. There's no solution. So you can see that this is not valid. Therefore, this is no solution. So you can write it like that, or you can put a line through the equals. Okay. Don't forget to do this, grade 11s. You will get penalized if you do not show one of them are not valid. Okay. Now, moving on to the next one. We've got to solve for x again. And what I'm going to do, guys, because normally what we would do here is we'd multiply through by the LCD and then get rid of the fraction. But in this case, if I had to multiply by this denominator, and I'm just looking at the highest powers here, we get x squared times x squared. That'll give us x to the 4. Now, you guys don't know how to solve equations with such high powers yet, okay? So what I'm going to do is I'm going to look for something that is repeating. So in other words, I've got an x squared plus x over there, and I have an x squared plus x over there. To make my life easier, I'm just going to say let k be equal to this thing that is repeating. So we get x squared plus x. So everything that I've highlighted in yellow there is now going to become k. So that will become k plus 11 over that little bit will become k, and we have minus 1 equals 13. Now, with my substitution, I can now multiply through by this denominator here, and things will be a lot easier. So the LCD here will be k minus 1. And I'm going to multiply everything by that k minus 1. So if I multiply this by k minus 1, we get k times k minus 1. Plus, if I multiply this by k minus 1, they will cancel, and I'm just left with 11 equals, multiply that by k minus 1, and we got 13k minus 1. Okay, let's just distribute. So we get k squared minus k plus 11 equals 13k minus 13. So I've just distributed into the brackets. I'm going to take everything to the left hand side. So we've got k squared. Here we've got minus k. If I take that to the other side, it becomes minus 13. So we get minus 14k. Then we've got 11 minus 13. Take it to the other side, it becomes a plus, and we get plus 24 equals to 0. This is a trinomial which we can factorize. And we get k minus 12, k minus 2. So that means that k is equal to 12, or k is equal to 2. But now remember, the question was to solve for x, and we've solved for k. So now I need to back substitute these values into my k so we can solve for the x. So for this one over here, we're going to get 12 is equal to, I've just made my k 12, equals x squared plus x. For this one over here, k is 2 equals x squared plus x. Just take this to this side and we get 0 is equal to x squared plus x minus 12. Factorize this. And we get x plus 4, x minus 3. So that means that x is equal to minus 4 or x is equal to 3. Likewise for this, just take the 2 to the other side and we get 0 is equal to x squared plus x minus 2. Factorize that and we get 0 is equal to x plus 2, x minus 1. So that means that x is equal to minus 2 or x is equal to 1. And just like that, guys. All right, moving on to question 2. They're asking us to solve for m and n. So that's normally a simultaneous type of question. So I just want to rewrite these equations out. Minus 2m plus n equals minus 1. Minus 2m plus n equals minus 1. I've just written the same one. Apologies, guys. It's the bottom one. N squared minus 7 minus m squared equals minus m. Okay, so with these simultaneous equations, you always solve for the easiest variable. So I can see here that this n here would be the easiest one to solve for. So n is equal to, take that to that side, and it becomes plus 2m. I can call this equation 1, and I can call this equation 2. Equation 1, equation 2. And now what I'm going to do is I'm going to substitute equation 1 into equation 2. So wherever I see an n, I'm going to replace it with minus 1 plus 2m. So that will be replaced, and that's the only one to be replaced. The rest are m's. So let's just tell them here what we're doing. Sub 1 into 2. Okay, so that there becomes now minus 1 plus 2m squared minus 7 minus m squared equals minus m. Okay, remember that we've got two brackets here, so we need to FOIL it. So I'll just show you guys. We've got minus 1 plus 2m minus 1 plus 2m minus 7 minus m squared equals minus m. So the first will give us 1. Outers minus 2m, inners minus 2m, so that's minus 4m. And then the lasts will give us plus 4m squared. Minus 7 minus m squared equals minus m. Okay, get like terms together. So we've got 4m squared minus m squared gives us 3m squared. Then we've got minus 4m. Take this to the side, becomes plus, so that's minus 3m. Then we've got 1 minus 7 is minus 6 equals 0. I'm going to divide 3 by 3 just to make our lives easier because it's a common factor, and we get minus m minus 2 equals 0. Factorize the trinomial and we get m minus 2, m plus 1. So that means that m is equal to 2 or m is equal to minus 1. So now that we've solved for m, I can solve for n. And all I have to do is just take both these m values and plug it into our equation 1, because we have an expression here in terms of m and n is equal to that. So I'm just going to say sub into 1. So for this one here, we get n is equal to minus 1 plus 2 times 2, because m is 2. And for this one here, we'll get n is equal to minus 1 plus 2 times minus 1. So here we get, that's 4, minus 1 is 3. And here we get, that's minus 2, minus 1 is minus 3. And we solve for both mn, mn. Okay, question 3. It's an inequality. So what we need to do is we need to FOIL this out first. Remember, guys, that squared means we have 2 brackets. Keep things basic, guys. Don't try and do anything funny by taking square roots and things like that. Just FOIL it out, get like terms together, and then you'll see in a second we'll be able to factorize it as a trinomial. Okay, so 2 brackets, we need to FOIL. So the first will give us 9x squared. Outers, minus 6x. Inners, minus 6x. So that's minus 12x. Minus 2 times minus 2 is plus 4, greater than 3x. Take that to that side, and we get 9x squared. So that'll be minus 12x. Minus 3x is minus 15x. Plus 4 greater than 0. Okay, this is a trinomial which you can factorize. Guys, please make sure that your trinomial factorization skills are up to scratch. Okay, as you can see, they appear a lot. So factorize this, and we get 3x minus 4, 3x minus 1. Okay. Now, if this was an equation, what we would do here is we would actually solve for x and then we would leave it there. But because this is an inequality, we need to draw up the number line and then do that whole thing. So before I draw up the number line, I need to find something called critical values. Okay, and that is like solving for it like normally if it was an equals. So if we had to solve for this one here, we would get x is equal to 4 over 3. This one here, we would get x is equal to 1 over 3. Okay, and those are our 2 critical values. So what I do is I draw up a number line. The smallest one goes on the left, the bigger on the right. So the smaller one is a third. The bigger one is 4/3. Okay, now we come back to this sign over here. Because this is not an equals one, these get open dots. If it was an equals one, remember we get closed dots. Okay, then it goes plus, minus, plus. Now, where do we draw our line? It says here, now we come back to this thing over here. It's saying that this thing must be greater than 0. So if something is greater than 0, it is positive. So it's positive in this direction, and it's positive in that direction. Remember, if we choose anything between 1 over 3 and 4 over 3, it would be negative, and we're not interested in that. So now we're ready to write up our solution. So we read from left to right. This is going down towards minus infinity, up to 1 over 3. Then we hop to 4 over 3, and then this one goes up to infinity. Now, infinity is never included, so they always get round brackets. Because this is an open dot, that's a round bracket, open dot, round bracket. If they were closed dots, these would be square brackets. Now that we've got 2 solutions, we need to join those 2 solutions by a union. Okay, so it's just saying that this solution union this solution, and then in the front we just say x is an element of these 2 solutions. Okay, right, going on to question 4, again just solving for x. So now we're going on to exponential stuff. Now, because there is a minus in between here, guys, I can't do my exponential laws, which is if bases were the same and we multiply and we add the exponents. Here what I have to do is I have to actually split. Okay, and what I mean by splitting is if we look at law 1, it says if bases are the same and we are multiplying, we add those exponents. Okay, and that's going in this direction like this. The nice thing with this is we can reverse it. If we've got it in this form, I can reverse it back to this. All right, and that's what we've got here, basically a to the m plus n. Okay, and it's in that form, so I'm just going to reverse it to that. So I've split this, and it becomes 3 to the x times 3 to the 3 minus. Again, I'm going to split this one, 3 to the x times 3 squared equals 486. Now we have 2 terms over here, and with those 2 terms, I have something that is common, which is this 3 to the x. I'm going to take that 3 to the x out as common, and we're left with 3 to the 3 minus 3 squared equals 486. Okay. Now, if you don't know what this is, if you can't work it out in your head, guys, just use the calculator. Okay, so we've got 3 cubed minus 3 squared, and we get 18. So this is 3 to the x times 18 equals 486. To get rid of the 18, we divide both sides. So we get 3 to the x is equal to 27. Again, guys, just on your calculator, 486 divided by 18, 27. Now that we've got this, I must think of something so that I can get bases the same. So basically 3 to the x equals 3 to the power of something must give us 27. So that's 3 to the 3. Now that our bases are the same, 3 and 3, our exponents must be equal. So therefore, x is equal to 3. And we've solved. Okay, going on to question B. Okay, first things first, I'm going to divide both sides by 2 just to get this on its own. So we've got to divide it by 2, and we get x to the power of 2 over 3 is equal to 16. Okay. Now, in order to get this on its own, I need to raise this to the power of 3 over 2, okay, to get the x on its own, because I just increase it by the power of the reciprocal of this. Now, reciprocal just means the opposite. And if I do that, these things will cancel. What I do to this side, I must do to this side, so 3 over 2. But here is the catch, grade 11s. Because that is an even number, that 2 is even, this will be plus minus. Okay, so whenever that's an even number, you must do plus or minus. All right, so over here, these will cancel, and we're left with x is equal to plus minus 16 to the power of 3 over 2. Now, I'm going to prime factorize the 16. And if we prime factorize 16, we get x equals plus minus 2 to the power of 4 to the power of 3 over 2. All right. Now, if you've got something to the power of something raised to another power, we multiply those exponents. So we get x is equal to plus minus. So 4 times 3 over 2 is going to give us, the 2 will cancel with the 4, so that's 2, 6. So it's plus or minus 2 to the power of 6. You can put that on the calculator and you get x is equal to plus or minus 64. Okay, so that was the main thing. If your exponent over here, if the numerator is an even number, it's plus minus. If it's an odd number, you don't have to do the plus minus. Okay, right, going on to question C. We don't work with things with negative exponents. So what I'm going to do here is I'm just going to make it 2x plus, now remember, the negative exponent is telling it wants to be in the opposite place. So here, now remember, that is one term, guys, 16 times 2 to the x. So what I'm going to do is, because this one's got the negative exponent, I'm just going to take the 2 to the minus x to the bottom, and we get 16 over 2 to the x minus 10 equals 0. Okay, so this looks very similar to the question that we did over here, question E, where we've got something very similar like that case there. Okay, so what I'm going to do here is I'm going to let 2 to the x equals k, and it will just make our lives a little bit easier. So let 2 to the x be equal to k. So what does that mean? That becomes a k plus 16 over k minus 10 equals 0. My LCD here is k, so I multiply through by k. So this multiplied by k will give us k squared, plus multiply this by k, they'll cancel, and you're left with 16, minus multiply that by k, and you left with minus 10k. Just rearrange things. You have a trinomial which you can factorize. And we will get 8 and 2 minus minus. So that means that k is equal to 8 or k is equal to 2. Now remember, we're not solving for k, we're solving for x. So I come back up to my substitution here. Remember that k is 2 to the x, so we get 2 to the x is equal to 8. 2 to the x is equal to 2. Now, very similar to what I did over here with this question, I'm going to try and get bases the same, okay? So here we've got 2 to the x is equal to 2 to the power of what? Gives us 8, it's 3. So that means that x is equal to 3. Over here, well, the bases are the same. We're just missing an exponent. So this has an invisible 1 over there. So over here, we get x is equal to 1. All right, so that's that one, guys. Question D. Okay, so this one, what I want you guys to notice here, and it always works out like this, grade 11s. If I look at these exponents, we've got a half and we've got a quarter. Now, this first one is double that one, okay? If you don't believe me, 2 times 1 over 4 will give us a half. So you see, this one is double that one. And whenever you get that situation where the one exponent is double the other one, you have got a trinomial, okay? So what I'm going to do is I'm just going to show you, I'll come back to this one. I just want to show you if we have something like this. 5x squared minus 11x plus 2. Now this you would be able to factorize. So you would get 5x minus 1, x minus 2, okay, and that's how we would factorize that. Now I want you to see the similarity between this one and this one. All I've done is I've just changed that x to x squared and that x just to x, okay, but it's the same thing. This thing here has a power of 1, so this power here is double that one, okay, and that's how you guys have always been factorizing trinomials. The one is always double the other one. Likewise with this. So all I have to do here is factorize it just like we factorized this one. So we have 5x, and it's always the smaller power if you notice here. So that will be x to the quarter. And it was minus 1. Then x to the quarter minus 2. So that means over here that we get x to the quarter is equal to 1 over 5. Or x to the quarter is equal to 2. Just like what you would do here. You would say x is equal to 1 over 5. Here you would say x is equal to 2. Okay. Now, because this one over here has an odd numerator, we don't have to do that plus minus situation. Okay. So all I have to do is just raise this to the power of 4 over 1. Okay, remember, raise it to the reciprocal. What I do to that side, I must do to this side. So these will cancel and you're left with x is equal to, now 1 to the power of 4 is just 1. Then 5 to the power of 4 is 625, I think. 625. Likewise over here, your numerator is an odd number, so I don't have to do the plus minus thing, only if it's an even number. So we raise this to the power of 4 over 1. What I do to that side, we do to this side. Okay, so that will cancel and you're left with x is equal to 2 to the power of 4 is 16. And we've solved it. Okay, going on to question 5 now, which looks like a sequence quadratic question. All right, so given the following quadratic pattern, 5 minus 4 minus 19 minus 40, determine the constant second difference of the sequence. So we've got 5 minus 4 minus 19 minus 40. So take this minus this. So minus 4 minus 9, and we get this minus this, yeah, and we should get minus 9. Okay, then take this one minus this one, so minus 19 minus 4, and we get minus 15. Then minus 40, minus 19, and we get minus 21. This row here is our first difference. Okay, so I just want to make a note here. First difference. Now what they're asking for is they're asking for the constant second difference. So we need to go from minus 15 or minus 9 to minus 15. How do we do that? So it's minus 15 minus 9. And we get minus 6. Likewise over here, minus 21 minus 15. And we get minus 6. And what you can see here, we're getting a constant second difference, which means that it is quadratic. Okay, so if this is constant, we get a constant second difference. All right, so we might need this information to solve the next questions. Then it says determine the nth term of the pattern. Now these formulas that I'm about to write up, guys, you aren't given, so you need to know them. So the first one is 2a is equal to the second difference. Okay, so the second difference here is minus 6. Then we get 3a plus b is equal to the first difference, in this case minus 9. Then we get a plus b plus c is equal to the first term, which in this case is this 5. Okay, so this is the first term. Now, notice what I've done here, grade 11s, is I'm always working with this diagonal here. Don't work with any other diagonal, always this first diagonal. So I just want to color code these for you. So the a plus b plus c is equal to the first term, which is 5. Then we get 3a plus b is equal to your first difference. Then we get the second difference is 2a. So those formulas there that I've highlighted, you will not get. You need to memorize them. Okay. So over here, I can solve for a, and we get that a is equal to minus 3. I take this, substitute it in here, and we get 3 minus 3 plus b equals minus 9. So that will give us minus 9. Take it to the other side, becomes plus 9. So we get b is equal to 0. Take our a, our b, substitute it into this one, and we get minus 3 plus 0 plus c equals 5. So that'll give us minus 3. Take it to the other side, becomes a plus, and we get c is equal to 8. Okay, now we're ready to write up our general nth term. Remember that the general equation is Tn is equal to an squared plus bn plus c. That is another one that is not given to you. I've solved for the a, the b, and the c. I'm just going to plug it into here, and we get that Tn is equal to, our a is minus 3, n squared, plus bn, b is 0, so that falls away, plus c, so we get plus 8. All right, then which term of the pattern will be equal to this minus 25,939? Okay, so somewhere in this original pattern, we have that minus 25,939 number, somewhere in here. Remember that this is T1, 2, 3, 4. So that's what we want to find. Which T number is it? So that's when I take this thing, set it equal to that, and I can solve for n. So we get minus 3n squared plus 8, because that is our Tn. And we set it equal to minus 25,939. And now we can solve. So all I'm going to do is take this to this side, minus 3n squared, and we get 8 plus 25,939, and we get plus 25,947 equals 0. Divide through by 3, or negative 3. So I'm going to take that, divide that by negative 3, and we get minus 8649. Okay, now equals 0. Now, if you get to this point, guys, and you don't know what to do, I have a funny feeling that this is a difference of two squares. Okay. So all I'm going to do is I'm just going to times that by -1. Okay, just to get a positive, and I'm going to take the square root of it, and there you go. It is the difference of two squares. So this will be n squared plus 93. Sorry, not n squared, just n minus 93. So that means